Okay, so today's big topic is molar mass. And what it tells us is the molar mass is the mass of 1 mole of a substance. 1 mole of a substance. Have you heard the term mole before in scientific ways, right? Yeah, Hannah, what do you think? Do you know what a mole is, or you just heard it before?
I've just heard of it.
Okay, a mole, I want you to think of a mole as similar to like a dozen. What does a dozen always mean? 12. Does it matter if I have donuts or baseballs or roses or whatever? Doesn't matter. It's always 12, right? A mole works the same way. It's just much, much, much bigger. It's a much bigger scale. Okay, so a mole, if we're looking at the molar mass of something, a mole of anything, right, I'm going to give you the number right now. 1 mole of anything is equal to 6.022 times 10 to the 23rd of any substance. Okay, that's a lot bigger than a dozen, right? But it's the same type of relationship, right? No matter whether we're looking at hydrogen atoms or we're looking at baseballs, right? A mole of baseballs would take up the whole school, right? 6.022 times 10 to the 23rd baseballs, that's a lot, right? But a mole of hydrogen atoms only weighs 1 gram, okay? So the molar mass just is talking about what's the mass of 1 mole of these items, okay? So does that make sense a little bit? When we talk about in terms of a mole, it's a unit of measurement, okay? So molar mass means the mass in grams of 1 mole of our substance. So you can find the molar mass of both elements and compounds. Okay? The molar mass of an element is found directly on the periodic table. Okay? And this is the way it works. The molar mass and the atomic mass are the same number. They're exactly the same number. Okay, molar mass and atomic mass are the same number. The only difference is their units and the scale to which we are looking at that mass. Okay, so when we look at the atomic mass of an element, we're looking at the mass of 1 single atom. Okay, so if I ask for the atomic mass of oxygen, that means I want to know what's the mass of 1 singular atom of oxygen. And what is it? 16, right? It's protons plus neutrons. If I wanted the molar mass of oxygen, I want to know what's the mass of 1 whole mole of oxygen atoms. And the answer for that is still 16. Right? But this time our units are grams, not atomic mass units. The only thing that changes between atomic mass and molar mass is the scale at which we're looking at it. A mole is much, much bigger than just an oxygen atom, right? A mole is 6.022 times 10 to the 23rd of those oxygen atoms. So the difference between molar mass and atomic mass is just that when we talk about molar mass, we're talking about many more of those atoms. Okay, we still calculate atomic mass and molar mass the exact same way. Okay, are we on the same page so far? Okay, so let's try some examples here. Okay, if I'm giving the average atomic mass of carbon is 12, what's my molar mass of carbon? 12, and what are my units for molar mass? Grams per mole. Okay, good. Do we understand what this G per mole means? Okay, this is what the unit itself means. Grams per mole, we're talking about grams over 1 mole. So if I know carbon has a molar mass of 12 grams per mole, what this is saying that is if I had 1 mole of carbon atoms, they would weigh 12 grams. Okay, if I put 1 mole of carbon atoms on a scale, it would weigh 12 grams. That's what it's saying. Okay? And if I put 1 mole of fluorine atoms on the scale, how much would they weigh? for fluorine. If I put 1 mole of fluorine atoms on the scale, how much would they weigh? About 19 grams, right? Okay, so we're on the same page here? The mole is the much bigger version, right? We're just looking at a bigger version of our scale. Okay, so that's where the units for atomic mass come. How many grams does 1 mole of that substance weigh? Okay, so they're both mass units. Just one's a lot bigger, one's a lot smaller. Okay, so let's practice here. If we want to find the molar mass of a compound instead of just an element, right? What's the difference between an element and a compound? Do we know? Perfect. An element is one type of atom, right? Like hydrogen, chlorine, carbon, those types of things. Compounds are more than one types of atom. So that's like water or salt or whatever. Those are all compounds. So if we want to find the molar mass of a compound, we're going to take into account every atom in that compound, and we're going to add all those molar masses together. So let's start with hydrogen and water. Hydrogen and oxygen combining to form water. Okay, you will need your calculator out. So let's try one here with water. How many hydrogen atoms do we have? In water we have 2. So I'm going to take 2 hydrogen atoms times its mass. What's the mass of hydrogen? The molar mass? 1, right? And we can keep that at 1. When we're really close to a whole number like hydrogen, carbon, oxygen, nitrogen, right? All of those guys, our really most used ones, are very close to whole numbers. We can keep them at a whole number, okay? So that gives us 2, right? 2 grams per mole. How many oxygen atoms do we have? How many? 1. And what's the molar mass of oxygen? 16. Okay, which gives us 16 grams per mole. Right, so here's our hydrogen atoms. Here's our oxygen atoms. We need to add those together to get the molar mass of the total compound, which gives us a molar mass of 18 grams per mole. Sometimes compounds are written with parentheses and numbers outside those parentheses. So I'm going to show you what we do with examples like that. Okay? The number outside the parentheses multiplies everything inside by that number. Okay, and I'll show you again once we get going here. But this is the example we're going to try next. So let's start looking at this molecule. It's called iron sulfate. How many different elements do we have in this compound? What are the different elements we have? There's 3 different ones, right? F, E, S, and O, right? Every time we get a capital letter, that means that's a different element, okay? So iron, sulfur, and oxygen. Okay, those are our 3 different compounds, or 3 different elements here, I'm sorry. So how many iron atoms do we have? 2, right? This 2 just goes right here for iron. So we take 2 times its molar mass. Okay, and what is the molar mass of iron? 50. Let's keep that one. I think that's maybe too much in the middle to round it. 55.8. I'm only rounding if we're at a 9, 6, an O, or whatever, you know what I'm saying? It's got to be really close to a whole number to be able to round, okay? So let's keep that at 55.85, okay? Cool? Okay, so let's plug that in. 55.85 times 2, 111.7. Okay. How many sulfur atoms do we have? this is where our parentheses comes into play. So SO4 is a compound, and this is saying that we have 3 of those SO4 compounds. So that means for sulfur alone, I have 3. Okay, that 3 gets multiplied in there. Okay, so here's what's happening. This SO4 is a single molecule. Okay, and there's 3 of those SO4 molecules attached around iron. Okay, so if we have 3 of those SO4 molecules, that means therefore we have 3 sulfurs. Okay, so sulfur's at 32.06. I'm going to keep that at 32.
Is that the mass?
32 is the mass. Yep, these are both molar mass. Okay, so now oxygen. Knowing what we know about that multiplication, how many oxygen atoms do we have? 3 times 4 is 12. Okay, so now we need to add all of those things together. This is what this molecule looks like, okay? I drew it out in 2 dimensions so we can see what it looks like. Okay? I've got 2 irons, 1, 2, right? And then here's this sulfate molecule, SO4. Right? You don't have to be able to draw this out. I'm just showing you how it works, okay? This is an SO4 molecule. It says here, because of this parentheses, it says that there are 3 of these SO4 molecules. So that's why I drew it out. So if I'm counting my total oxygens, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? That's where that 12 oxygens comes from. Does that make sense? Okay, so if we added all of those together, what did we get for our final molar mass? Somebody say it with confidence. Perfect. 399.7. And what's our units for molar mass? Grams per mole. Good. What if I had asked you for atomic mass? What would the units be? AMU, right? We'd solve it exactly the same, except the units would be AMU instead of grams per mole. Okay? Okay, try these 3 on your own. Yep. These ones, none of these have parentheses. So that means the subscript only goes to the element directly in front of it. Okay, so without parentheses, the 3 only goes to the oxygen, not to anything else. Okay. Okay, on the first one, Grant, what do we have? 69.87. Would we agree? Right, depending on the rounding, right? We're good if you round it up to 170, that's fine.
I didn't. 86.
You had 186? Oh, 0.86. Fine. Yeah, rounding here is not a huge deal. We need to be in the ballpark. Okay? 170 would work, yeah. I would really probably not round silver to a whole number. 107.8, right? I would have kept that at 8.7 or 8.6. Okay, so I would not have rounded that to a whole number. Okay? So silver is not roundable, magnesium is not roundable, chlorine is not roundable, everything else here is. Okay.
If we rounded the silver on the text,
I would probably take off, yes, a little something. Okay, we want to keep numbers that are close to whole numbers. If we're at a 9.7 or above, or an O, 1 or O something really, most of them that are 0.0 something, I'll take at a whole number. But for the most part, if they're in the 0.8 range or the 0.1 range, we need to keep that decimal place.
just one decimal place for
Yeah, for the most part. Okay. Annie, what'd you have for the second one?
95.2 grams.
95.2 grams per mole. Do we agree?
I had 0.3.
Yeah, that's fine. Yeah. Okay. 95 point something. Chlorine should have been 35.5, right? I round that 35.5. If you kept the 4.5, that's great. That's probably where it came at. Okay, last one. Sarah, what'd you have?
142.1 grams.
Good. I would have kept all these at a whole number, so I would end up with 142, but that's just fine. Okay? Do we all agree there? Okay, very good. Just a reminder that for molar mass, we use grams per mole. Atomic mass is AMU. Okay, so there's a difference there in the terms of the scale we're looking at. AMU is one single atom, right? Molar mass is a whole mole of those atoms.